Find the radius and the interval of convergence for the given power series. So we have sigma 3n xn. Xn means x minus 0 to the n. So the center is 0. Okay, this power series always converges when x equals center, x equals 0. So for x not equal to 0, this power series may still converge, so we will determine that. For x not equal to 0, let's find the following limit. Limit of an plus 1 over an as n goes to infinity. Okay, where an is the given term, this is an, so an plus 1 will be just replace n throughout by n plus 1. So this limit is same as limit n goes to infinity of an plus 1. So this is 3 raised to n plus 1 x raised to n plus 1 over 2 n cubed is n plus 1 cubed plus 10. Okay, that's an plus 1 divided by an. An is what we have there, 3n xn over 2n cubed plus 10. Okay, this limit is equal to let's write in product. 3 to the n plus 1 is same as 3 to the n times 3 to the 1. Same thing here. So this is 3 to the n times 3 to the 1 times x n plus 1 is x to the n times x to the 1 over 2n plus 1 cubed plus 10. This division into multiplication, 2n cubed plus 10 on the top, 3n times xn on the bottom. Now there should be some cancellations. 3 to the n, 3 to the n, xn cancel. Then let's see, 2n cubed plus 10, 2n plus 1 cubed plus 10, these are the positive numbers, so we'll keep here with limit because limit n goes to infinity. This 3 raised to 1 is 3 and x, they do not depend on n, so we can pull all the way outside. Absolute value of 3 raised to 1 is 3. Okay, just 3 outside, and absolute value of x, that is also outside. Limit n goes to infinity of 2n cubed plus 10 over 2n plus 1 cubed plus 10. Okay, we don't need absolute value anymore because these terms are all positive. Okay, let's find this limit. By the way, this is infinite limit. When n goes to infinity, from here only the leading term matters, 2n cubed. Same thing from the bottom, n plus 1 cubed. If we multiply n plus 1 3 times, then the very first term will be n cubed, so 2n cubed will be the leading term, 2n cubed, 2n cubed. So this limit is just 1. Okay, so we have 3 absolute value of x, and we know from the ratio test the series converges when this limit is less than 1, and the series diverges when this limit is bigger than 1. Okay, then by the ratio test, the series converges if this limit is less than 1, and the series diverges if this limit 3 absolute value of x is bigger than 1. Okay, that is same as absolute x divided by 3 1/3. Okay, so the series converges when absolute x is less than 1/3, and the series diverges when absolute x bigger than 1/3. So 1/3 is the radius of convergence. Thus the radius of convergence, let's say r, is 1/3. Okay, now to find the interval of convergence, let's look at the real number line. So the center is 0 in our case. and radius is 1/3, so we go 1/3 to the right and we go 1/3 to the left, negative 1/3. Okay, since the ratio test fails when this is equal to 1, we don't know whether the series converges or diverges at x equals negative 1/3 and 1/3. We know in between negative 1/3 and positive 1/3 the series converges, but we need to test for the endpoints as well. So we do separately. When x equals, let's say, left endpoint negative 1/3, the series becomes n from 1 through infinity. Let's go up and see what was the limit. In fact, 0. So x is now negative 1/3, 3n negative 1/3 n. Okay, this is 0. 3n xn, x is negative 1/3 n over 2n cubed plus 10. So we are replacing x by negative 1/3 in the series, and negative 1 to the n on the top, 3 to the n on the bottom. Okay, negative 1/3 to the n, let's consider negative to the top, negative 1 to the n on the top, 3 raised to n on the bottom, and then 3n cancel. So this series is in fact n from 0 through infinity, 3n cancel, top bottom, negative 1 to the n, okay, and left over 1 over 2n cubed plus 10. Okay, 2n cubed plus 10, which is an alternating series. Okay, this is an alternating series, negative 1 to the n, 1 over 2n cubed plus bn. Now we will apply the alternating series test to see if it converges. Okay, so this is bn for alternating series. All we need to show is these terms decrease and they decrease to 0. When n is very, very big, the top is fixed 1. So when n is big, the bottom is increasing. Consequently, the fraction is decreasing. Yes. Okay, these terms are decreasing. And when n goes to infinity, when n is very, very, very big, this is very big, infinity, 1 over infinity, 0. Okay, that means by the alternating series test, this series converges. Which converges? Okay, so the given power series converges at negative 1/3. How about the right endpoint? So we need to test in the same way. When x equals 1/3, the original series, the given series, becomes n from 0 through infinity of 3 to the n, xn, look at the question on top, so 1/3 to the n over 2n cubed plus 10. Now this is 1 to the n, so positive 1 to the n is just 1, 3 to the n on the bottom, 3 to the n cancel, so basically 1, just 1 on the top, over 2n cubed plus 10, n from 0 through infinity. Now we need to test if it converges. Okay, when n goes to infinity, 1 over infinity, 0. So we cannot use the test for divergence to show this diverges now. But look at this, the term 1 over 2n cubed plus 10. 1 over 2n cubed plus 10 is about, if we just take the leading terms, 1 on the top and 2n cubed on the bottom, we don't need to, so 1 over n cubed. So we can compare this series with the series 1 over n cubed, and we know this series 1 over n cubed, okay, this converges, being p series with p equals 3 bigger than 1, this converges. In fact, 1 over 2n cubed plus 10, this series is smaller than, the term of this series, this term 1 over 2n cubed plus 10 is smaller than 1 over n cubed, because the bottom is bigger. 2n cubed plus 10 is bigger than n cubed. And since this converges, this series also converges. Or you can take the limit comparison test. Just find the limit of 1 over 2n cubed plus 10 divided by 1 over n cubed, and when n goes to infinity, okay, if you do this work, n cubed on the top, it becomes 1/2 positive. So this series and this series behave the same. Since this converges, this one also converges. Okay, you can work that on side. Okay, what I'm going to say here, we have this series which converges. Okay, I would say compare with the series 1 over n cubed, and from now we cannot go from 0, so 1 through infinity, doesn't matter. Take the limit ratio and we'll find a positive number. That means they behave the same. Okay, so the right hand point, it also converges, so this is also included. So the interval of convergence will be including -1/3 and including 1/3 and everything in between. So thus the interval of convergence is bracket -1/3 through +1/3.